start this lecture in the Student Computer Science Festival here in Krakow. We are welcoming Professor Cay Horstmann. He wrote, of course. He's the author of very many books on Java, so if you are a Java programmer, and you likely are if you came here to this lecture, then you probably have heard of him. And he will be giving a lecture on Java. What were they thinking? A look behind the design decisions, both good and bad, that made Java what it is today, and what they mean about their future. So I'd like for Professor to start the lecture. By all means, take the floor.
All right, thanks very much for coming. So we're going to be talking about Java today, so I wanted to start with a story. In 1995, my good friend Gary Cornell gave me a call, and he said, "Hi Kai, we're going to be writing a Java book." I had written a bunch of books at the time, he had written a bunch of books at the time, but there was no denying that neither of us knew any Java. So I said, "Hey Gary, we don't know any Java, do we?" That was in 1995. And he said, "But I got a book contract." And so, over Christmas of 1995, we learned more Java than just about anyone in the period of 2 months, and wrote I think at the time, 350 pages book of Java 1.0, which was not a very complicated language. That book is now at 2 volumes and about 2,000 pages, and it has sold literally 1 million copies. So it's always good to be at the right point, at the right time, and get a call. When you get a call from someone who says, "Hey, we're going to do," then go and do it. All right, so Java started out way back before many of you were born, probably, as an internal project at Sun Microsystems that really had no reason to succeed. And it failed in its original purpose to be a system for doing consumer devices. Not one of the consumer devices that were prototyped were ever sold to anyone. There was a programming language that gratuitously came with these consumer devices, designed by James Gosling, the so-called Oak language, that actually turned out to be a pretty good language. And at one point, the marketing manager realized that Oak was not a name that would get at the hearts and minds of the programming community, and they changed it to Java because of coffee, you know. And in 1995, they accidentally built something that turned out to be useful, namely a browser that could render stuff that was delivered over the internet, which was not possible then, which I know for you is unimaginable, so you'll just have to trust me. And in 1996, Java then was born. It had a tiny API of about 200 classes, and the language manual was about 200 pages. Right now, the number of classes is about 5,000. It actually had more at a time, but some of them had been withdrawn since, and the language spec is now at about 800 pages. It is one of the 4 major programming languages, if you look at any old surveys, together with C, C++, Python, and JavaScript. Of course, there are many other programming languages, but these are, by any measure, the top 4. And it is, of those 4, probably the most well-designed language, even though today I'm going to be complaining about some of the things where it could be better designed, but anything could. So it is also the most common language in computer science education, and probably many of you have had Java as your first language. Like I said, no programming language is perfect, and I like to talk about languages because that's our most common tool that we use for everything. That is what we do to express our thoughts. And to think about a language and to understand more of a language, I think is always super useful. Every language has its limitations, every language has its strengths, and to know more about it, I think, is something that's never a waste of time. So I hope you'll agree. So, and I'll just start out with asking and answering some questions that you might have thought about when you used Java. Remember when you first learned Java, and there was public static void main. And you may have had one of 2 kinds of professors. There's the kind of professors who are very systematic, and to explain to you what public means, what static means, what void means, what main means, what string args means, and at that point you've probably all lost the will to live. Then there's the other kind of professors who said, oh, don't worry about this, copy and paste it. That would be me. So, but it's weird, right? We have a language that's proudly designed as an object-oriented language. It was really the first of the major languages that came into being and say, this is first and foremost an object-oriented programming language. This is not something with objects grafted on like C++ or Python. This is not something like JavaScript, which has weird objects. This is the OO language. It does objects right. So why is main static? One could have made it so that when you start a program, that instead of calling the static method, when you say Java prog, it could construct an instance of the class prog, and you would just put the code of the program inside the constructor. That would be object-oriented. And you wouldn't have to learn about public static void on day one. Okay, maybe about public. Or one could make it so that there is a constructor that takes the command line arguments as a parameter. Or one could make a no-argument constructor that then calls a non-static public void main. That'd be nice too. You first construct the object, and then it kicks off in that main method. No static. One could have made it so to even more object-oriented, and that every program extends some class app. There are some languages that do that, just not Java. And in fact, JavaFX does exactly that, if you've ever seen it. And so there's no good reason why none of these one of these mechanisms were taken. No one gave it any thought in 1995. It was simply, the idea was this should be easy for C++ programmers to use. Nowadays, this is not a very good reason, because how many C++ programmers are there still in 2021? Like 19? I mean, of course, there are many C++ programmers, but there are not that many who make the move from C++ to Java. Most people these days start out in a language like Java. So that whole reason has gone away. And so it's just that at this point, no one wants to tinker with this particular aspect. Many people have proposed to make this nicer, but it solves only a small problem. So that's why it is why it is. Oftentimes it goes like that with history. So except there was one time when Oracle was hot to trot to make JavaFX easier for the masses, and at that point it was important enough to them that they did rig the Java launcher just for JavaFX. Now JavaFX is long forgotten, and that mechanism is there only as a vestige to at some point be removed again. Oh, by the way, why is static called static? Because of the static, like in the United States, one talks about the static on a television set when you just see that. You don't television set is probably, but there used to be a time when the television, when programs were shown in this set that received stuff over the air, and if it received nothing, then you saw this static pattern. So why static? Well, static has a weird history. At one point, the C language had static variables that were really weird. There were variables that were local variables, but they stuck around. When you re-entered the function, the variable was still there. It wasn't deleted and recreated like normal variables are. You could use it like for a counter, like this in this example. And then C, at one point, had the bright idea that not every variable that was a global variable had to be public. And so they could maybe want to hide some of these global variables. Now they had a problem. They didn't want to have a new keyword private, because when you introduce a new keyword into a language, then if it was used as the name of a function somewhere, then that would break. So they said, hey, we have this keyword static that could be unambiguously used here to say private, and we just use static when we mean private. That's what language designers sometimes do. And so in C++, they had a third problem. They had these variables that only belong to classes and not instance variables. They didn't want to name them class variables because for some reason they thought it would be funny if you have a class foo and then inside there you have a class int x. And so they called them, for lack of a better keyword, static. And so that's why the name static comes. It's completely meaningless in C++ and in Java. It always astounds me that some people try to give it some meaning. It is just two versions removed from something that made sense in C. Just it's keyword reuse. That's how it is. All right. So in other O languages, one calls these class variables, and that makes more sense. You've learned that in Java, everything is an object. Right? Even arrays are objects. But there are these 8 primitive types, and you had a quiz at one point in your life where you had to be able to list them all. So why were they primitive types? They could have been class types. Well, we have these wrapper classes for them, of course, but you have this phenomenon that you have both the primitive types and the wrapper classes. And so the rationale for all of this was that until Java 5, no one really cared. It was natural to say, yeah, these small data types, they are just easily represented as words in the machine, and so why not just have them like that? Then in Java 5 with generics, all hell broke loose, because now we have array lists, and if you want to have an array list of integers, then you can't use an array list of int, because all of the objects erased to something. That doesn't work. In Java 8, things got much worse when you had function types, and so you can't have a type function int. That's why we now have int function and double function and int to double function and double to long function and all of these types, and it's become a real pain. And so you have to use these wrapper classes all the time, but the wrapper classes are inefficient. And it would be nice if the JIT, the just-in-time compiler, could say, oh, I know this thing is an int, so I can just make it more efficient behind the scenes and use an int array instead of an integer array. And that would have been possible, except for another fateful decision that I'll talk about in a minute. Because unfortunately, the integer wrapper classes that were introduced in Java 1.0 have identity, and some clown could have made a lock on one of them, which is something no one ever does, but there's someone out there that did that. And so pretty soon, the Java folks realized that they can't, in order to stay compatible, and Java is so amazingly compatible with old versions, they can't defend against that. That will change. There is a project Valhalla that in the next 2, 3, 4, 5 years, who knows, is going to kind of revolutionize what goes on in the very basics of the Java virtual machine. And at that point, yes, you will be able to make an array list of int, and what at that time will be 30 years of pain will finally be cured. So Java is alive and kicking. There is a lot of development going on, and so some of the original sins, so to speak, are now being worked on. Of course, it would be easier if one didn't have the 30 years of history, but we do, and so we'll have to wait until the wizards are done with resolving all of these problems. But stay tuned. There will be super efficient implementations of not just arrays of primitive types, but there'll be other types that you can define yourselves that are like primitive types, things like points or dates, and you will no longer have these inefficient levels of indirection. So why do these wrapper classes have this identity? So why is it so that when you have 2 new integers, that they're different? Why is the first new integer the same thing? When you call new, it makes a new object every time, and they decided that that was an important invariant that everyone knows. And so when you call new twice in a row, then it gives you a new object. And that's kind of bad, right? So you could use integer.valueOf, which is a factory function, always better than a constructor. And at that point, you call it twice, and you get the exact same object. That's nicer, except, yeah, so the moral is factory function is better. And in 1995, nobody thought of these constructors as particularly evil. And it's only in 2017 that finally the designers of Java said they are evil, and so you should no longer call new integer of anything. You get an error, a warning. Pretty soon you get an error. And as of today, even those factory functions aren't so great. When you call it with a larger number, you still get a new and separate object. So we're slowly getting to the point of understanding that for these small classes, that actually objects aren't great. For these small classes, you want what's called value semantics, and that too will come with Valhalla. So for your own coding, the takeaway is stay away from constructors when you can. Constructors aren't as good as they're cracked up to be. Use public factory functions and private constructors. Another thing that's weird about Java primitive types is you have these types short and float. Did any of you ever use short and float? I think the only time that anyone really uses them is for certification exam questions. So why are they there? You know, they're shorter. Float uses 4 bytes instead of 8 bytes of doubles. And of course, it has a shorter range. Float literals, you have to put this icky suffix f behind it. And you have to worry about rounding. And anyway, anything that you do in float gets instantly translated into doubles, and so it does not even any faster. With shorts, it's kind of the same way. Shorts always get translated into ints. And so the takeaway is you should never use float or short, except if you have an array of millions of them. In that case, you know, go ahead. But otherwise, they're kind of a waste. And so it always astonishes me how, like, every Java book, myself included, you know, lists all these 8 primitive types as if the students should learn them. You should probably not learn them. Bytes, on the other hand, seem kind of useful because you use bytes when you do any kind of, you read a binary file, you need to figure out what's the binary data in there. Maybe not everyone does that, but I mean, I've certainly done it many times in my life that I needed to do something with some particular binary file. In Java, bytes are signed. So that means a byte does not go from 0 to 255, but it goes from -128 to 127. Why? It's only there to torture programmers. Because look at your typical computation. You read a byte. You read another byte. And now you want to say the first byte plus 256 times the second byte. Well, that does not work to get you the value of a short, because if one of them is negative, then the arithmetic just does not work. So why'd they do it? In C++, you have signed and unsigned. That takes care of this particular problem, because then you can say, I want to have an unsigned char for a byte. But it's also kind of risky. And so in Java, they decided that they didn't have anything to do with the signed, unsigned thing, because if you have both signed and unsigned, it's just a question of time until they get mixed up with each other, and you have programmer's errors. So he said, all types shall be signed. It's simple, it's consistent, even though it's inconvenient, except for char. The char type goes from 0 to 65535 because it would have been super, super inconvenient to have that one as a signed type, and so they decided to have that one as an exception. And so in 1995, Unicode was a 16-bit code, and so it made sense to have it as an unsigned code. So the remedy is simple. If you ever need to do byte slinging, make sure to never actually use the byte type until you store the byte. At that point, you can always use them as ints, because they come in when you read them as values between 0 and 255 with a -1 if you're at the end of the file. Just always compute them as ints. It'll work fine. They're in the normal range. And then at the very end, then you can cast them to a byte. All right. Since I was talking about characters, I just wanted to dig into that a little bit more. Depending on when you were born, you may know this intuitively, but I'm always amazed how many programmers I talk to who are not really familiar with that. So to the right, you see a tropical drink that we all like to have right now. And it, of course, is encoded in Unicode, like everything is. So let me talk a little bit about the Unicode history. So way back when, there was ASCII, 7-bit, 1 bit for error checking, because it was on punched tape, and sometimes those holes weren't read correctly, and so it was useful to know if one of the holes was gummed up, and that's why you had that extra bit for parity checking. Then many other countries said, oh, hey, we can actually add, throw away the error checking, have another 128 characters, and we can add our own funky symbols to it. I'm sure there was a Polish code at the time, and at least there was a Western European and an Eastern European variant to handle all of those in 8 bits or 1 byte. Of course, the Chinese, Japanese, and Korean, they had many more characters. 1 byte was never going to kick it. And so they had various codings that preserved the original ASCII and then had some switches to turn into longer characters. And it was a mess because they were all different. Unicode was developed to unify all of these, hence the name. And in Unicode 1.0, everything was fine. All of the known characters, known to anyone in the world, plus enough space for hieroglyphs and Klingon, were actually put in 16 bits or 2 bytes. Then Java was born, and it was one of the first languages, if not the first language, that proudly adopted Unicode and said a char shall be 2 bytes that encodes every character ever known to man. 2001, something nasty happened, and the Chinese, who really could have known this in 1996, right, they realized that they had more than 60,000 characters, that there's now a total of 100,000 or so Chinese characters. Where they all found them, we don't know, but they did. And so that blew out of the bounds of a 16-bit code. Right now, it is a 23-bit code. If we had plenty of time, I could explain to you why 23. And so you can't put it into a single char anymore. You need a different way of encoding it. There are 2 different encodings that are known to, that are widely available. So everything on the internet is encoded with a scheme called UTF-8, a variable length code with 1 to 4 bytes per character. In Java, because it started out with 2 bytes, they use a different code called UTF-16, where one has either 1 or 2 char values to encode. And so our tropical drink here has 2 char values, so the code point has 2 char values, and that is a real pain because it means that anytime that you want to deal with strings, that you need to know, is it 1 char or is it 2 char? It used to be that people said, oh, I don't really care because I don't have any customers who need those 100,000 Chinese characters. But now, everyone uses emojis. You want to process anything, it might have emojis in there, and so you do kind of care, and you have to start becoming aware of this. So the takeaway is that don't ever use char. So if you find the forward char in your code base, you're just asking for trouble. Just always use integer code points, and you just be aware of the fact that the way they map to strings can be complex. Anything that you get out of index off and so on you can trust, but don't try to think that you can count characters as the difference between 2 indexes. You can't. All right. A weirder phenomenon is you can actually, if for whatever reason you want to write cryptic Java and amuse your friends, you can use the Unicode escapes right in your Java code. So you can, instead of saying hello world in double quotes, which is kind of boring, you can use the Unicode code to surround that. Why would you ever want to do that? Well, the reason is, and you can define variables in Java using Unicode. So here we have the variable pi as 3.14 and so on, and you can use the Greek letter pi as long as you know how to type it. There are many ways of typing it. For those of you who use Unix, for those of you who use Emacs, this is Linux and Emacs. I'll give some links. It's really simple. But I'm sure even in Windows, there's some way. You buy a Greek keyboard, you plug it in, and you type pi, and then you change the other keyboard. Now, of course, there are other ways. So these days, people are much more likely to put in both variable names and comments in whatever language it is that they program in and that the readers of the code like to read it in. Then there is the painful question, well, since there are different character encodings for the files, which encoding should you use? Well, there's, of course, in 2022, only one reasonable choice. You should use UTF-8. But you'd be surprised. Every week I get something from my students in Germany, and they don't use UTF-8 because they use Windows, and the default encoding is whatever the Windows code page is. And I can't actually, really, the compiler will not compile their file. So this is a stupid pain. And so because in 1995 this pain was much bigger, the Java designers said, oh, we like this ability that source code can have any Unicode characters, but what about interoperability? And so they said, hey, you want interoperability? We give you interoperability. You can always write every Unicode character with a \u and the 4. And it doesn't matter, it doesn't have to be inside a string. Any will do. So you can perfectly well, in this snippet of code here, express the various bits and pieces in Unicode. Here we have the variable name and the comment back there in Unicode. And all that stuff is processed before parsing, weirdly enough. And because it's processed before parsing, you can put even special characters, semicolons, quotes, in Unicode if you want to make your file completely unreadable. Give it a try sometime for great fun. As a particularly weird fact, oops, where have it? Oh, come back here. Yeah. You can even write \u, and then you can have any number of u's. Why any number of u's? Because that way, that converter that converts from UTF-8 or whatever into this impoverished ASCII can, if you already had a \u in there, turns it into a \uu, and then when you undo the encoding, then it can take one of the u's away, and it gets back to where you originally were. Think about it for a minute, and you'll see why that works. So, trivia takeaway number 1. You don't like braces, maybe your keyboard doesn't have it. You don't like quotes, just use the \u sequences. It'll become second nature really soon. And if you really want to, a few more u's can't do any harm. And so go for it. All right. So going on, another trivia fact here. There's a bunch of reserved words or keywords in Java. And 2 of them, namely goto and const, are keywords, meaning you can't use them as variable names, as function names, as identifiers, but they are not defined. They're not, it's assessed explicitly, they're unused in the language manual. So while goto was a keyword in C and then in oak, and const was a keyword, and const was at one point changed to final, because if you use references, const doesn't make so much sense. The thing that you're referring to might be mutated. And so that final means that's the final assignment to this variable. But they kept const and goto around because at the time, they were in the habit of taking working C++ code, and I must say did the same thing in 1995, 1996, and copying it into a .java file and then fixing it up until it compiled. And so if you had a stray const or goto into your code that you had all forgotten about, then the compiler could give you a decent error message and say, hey, this can't possibly be right Java code. That's why they kept them in there. That's the only reason. So another trivia fact, Java 1.0 had some number of keywords, 20-something. And after Java 1.0, only a very small number of keywords have been added. They are assert, enum, StrictFP, and underscore. Give yourself a pat on the back if you knew that underscore is a keyword in Java. It's been a keyword since, I believe, Java 12 or something. They've done that so that they can reserve it for a future use that they have in mind. You may know assert and enum. Enum is pretty common. Assert, not so much. StrictFP, I'll actually talk about in a minute. Then, starting with Java 5, they gave up adding new keywords because every time you add a new keyword, there's someone out there who has a variable called assert or enum or whatever, and any new keyword that they would come up with. And so all the new keywords are now what's called contextual keywords. So when var was introduced in Java 9, they made it so that when var is at just the right place, var gets passed as that thing to introduce a variable whose type is derived from the right-hand side. But if it's used anywhere else, it can still be an identifier. So it's perfectly legal Java to say var equals. The first var is the keyword, the second var is an identifier. So look at the new list of keywords and have some fun in coming up with unreadable Java, where you try to use as many of these contextual keywords as possible as identifiers so that your program still works, but it baffles your friends. And so they do that because they don't want to break any old code. So newer keywords, we're going to see more and more of those because keywords are always necessary for new features, may have hyphens in them. There's now, since Java 14, I want to say, I may be wrong, certainly Java 17, there's a keyword non-sealed, which clearly could never have been the name of an identifier because of the hyphen. But I'll challenge you, come up with some code where non-sealed is used as a subtraction, non-minus sealed. You can write such code if you use it in just the right place. All right. And another trivia fact, true, false, and null are not actually keywords, they're literals. It says so in the Java language specification, so if you need to have a bet to win a beer, there you have one. So what's with good old StrictFP? So that's another weird story. So Java was designed, bless its heart, as a write once, run anywhere language. It was really the first mainstream language that had that noble goal, that no matter where you run it, that you should get the same results. And so with floating point, they said, well, there's a floating point standard, IEEE 754, that says in great detail what should happen with any kind of round of scenarios, with the trigonometric functions, and so on. And so they said that's what Java does. Any floating point semantics is that IEEE 754 semantics. And so you can run it on any processor. At the time, there were more processors than we have today. But even today, new processors come and go. And now we have ARM, which we didn't have then. And so the idea is the same computational results should come. Your code runs anywhere and it has the exact same result. That's how it should be. In C and C++, this was never quite the fact and was always a stupid pain. And so Java said, we'll fix that. Well, then Intel was not on with the program because their processors that they had in the late 90s, they could do this, but what you'd have to do is you'd have to, because internally they said for the greater good, to have better control of a roundoff, internally they didn't use 64-bit for doubles, but they used these extended doubles that used 80 bits, and that's, I guess, good because fewer roundoff errors. But it was really bad for Java because if one wanted to do true Java on an Intel processor, one had to truncate after every floating point operation to 64-bit. It was enormously expensive. The numerics people hated it. They said, this is just unusable for numerical work. And so in Java 1.0, they said, okay, write once, run everywhere. Sounds good, but in practice, you can't really do it. And so we allow the Intel semantics, if that's what a virtual machine wants to do, and it's still true and honest Java. But if you really wanted to have that old behavior, then you can tag your method as StrictFP, and then it'll compute slowly but reliably and 100% the same. And so a few people used that when they needed that. Nowadays, 20 years later, the Intel processors no longer have this hiccup, and you can turn them into straight 64-bit mode without much problems. And so that StrictFP thing is gone. In Java 17, it's gone. It no longer has any meaning whatsoever. So here you have a keyword that over a period of 25 years has come, and it has gone again. That's how language evolution sometimes goes. One wishes one could develop a language completely independent of the facts of life, but when reality is in the way, that's what a language designer has to do. More language design. Goto. So I said there's no Goto in Java. Why is there Goto in C and C++? Everyone knows that Goto is bad, right? There's an ancient article, Goto considered harmful, and your programming language instructor must have one point told you, you should never use Goto even if you can. It's bad for you. And still, people use Goto every once in a while. Why would they use Goto? The most common reason in C and C++ why it's used is if you have a multiply nested loop and you want to get out of multiple indentations of nesting, then Goto is kind of the Goto mechanism. Sorry about that. And so in Java, they say, well, we don't like this Goto. We're going to give an alternative for breaking out of a multiply nested loop. And that is the labeled break. Has anyone in this room ever used a labeled break? Okay, very good. Not me either. Oh, there's one. Okay. This is something that probably every professor teaches because it's part of the language, and it's completely useless knowledge. I've looked it up in, there's also a labeled continue. So I've looked it up in the Java API, which has a very large number of files, and there actually are a bunch of use of unlabeled breaks, of course, mostly in switch statements. There's even a surprising number of unlabeled continues, another statement that I never use, but there's only a tiny number of uses for the labeled break and the labeled continue. So this is, if you look at how many total lines of code, there must be millions and millions of lines of code in there. So it's an infinitesimal part of it. And I've just at one point said, I'm just not going to do it. And so you can always use an extra Boolean variable, of course, at a tiny extra cost. So does anyone use labeled continue? The practical answer is there is one person out there who uses it. And it was probably not worth adding it to the language for that complexity. But that's the trade-off that these language designers do. You put something out there, you don't quite know whether people are going to use it or not. And in this case, the answer was, it was a waste. All right, so don't teach anyone labeled continue. C++ has a comma operator. So in C++, you can say an expression, and then comma, and then another expression, and the value of that is the value of the second expression. And every once in a while it's used, and it's kind of similar to what's called block expressions in other languages. So if you have something with a side effect and then the value that you actually want, in Scala, for example, you put it inside braces, and then the value is the value of the last thing, of the last semicolon. So these things do exist in languages, but in C++, they're most commonly used if you have a loop where you have two variables, where like I and j, one goes at the beginning, one is at the end, and they move towards each other. And then at the very end, you want to say I++ and j minus minus, but that slot only gives you one expression that you can put in there. And then with a comma, you can shoehorn two expressions where only one is expected. So that's the comma operator. Having the comma is, of course, intensely dumb, because there's so many other places where a comma is used, like inside parameters. And so there's there are all these ambiguities where the comma operator is can be confusing. In C++, you can even overload the comma operator, and I would very much encourage any C++ programmer not to do that. It could be super confusing. So in Java, they said, well, we're not going to have anything to do with anything confusing as that. You can still use a comma to define two variables. And now here's the trivia fact. And you can use it in the final slot, in the third slot of a for loop. Oops, and I forgot, the code got lost. Yeah, what a shame. So if you look at the code that you have here, where this code actually is also valid Java. So trivia fact, the third slot of a for loop, you can put a comma. That's the one place where a comma operator-like thing works. So it would have been nice to actually have block expressions in lambdas, because they would have been worked well. We have block expressions in the language because they would have worked well with lambdas, but that was a road not taken, and I'll pick that up in just a minute. Another trivia fact: why is it that when you define a variable, like here, or a method, and if you don't put public, private, or protected there, why is it package access? Because if you think about it, that's never what you want, right? When's the last time you used package access for anything? Every time that I can see that I did it, it is because I forgot to put in public or private. Not enough coffee or something. And then later I put in the public or private. I never want package access, but that's the default. So why have a default that's always wrong, or almost always wrong? And so, in O, fields should always be private. And most methods should be public, and some methods should maybe be private. So maybe one should make private the default for fields and public the default for methods. Sounds like a reasonable thing. But then there would be two defaults. And so that's maybe confusing. And that's one reason why they did it. And the other is that in 1995, package access didn't look all that bad. Packages were kind of small. And so they thought it was perfectly reasonable for one class to look at the private implementation of another class as long as it was in the same package, because presumably they were written by the same person, and that person understood what they were doing. Nowadays, we think that's wrong, but in 1995, that's how it was. And that's also why protected is so weird in in Java. I mean, don't ever use protected, but if you do, you need to realize that protected is not like C++, it's protected plus package access. So it's an oddball feature, but that again is because the world looked different in 1995 than it does now. So just always use private fields. These days, I think that's kind of pretty clear. And nowadays, of course, there's modules that deal with packages and where you can seal packages much more than you could at the time. I'm not going to talk about modules. Now the trivia facts, why are package names the way they are? And so you know how a package name works. It's like com.horstmann.something. And the reason that they are, and they match the directory names. Why they match the directory names? Because that way the compiler can find the classes in an instant. In 1995, it was considered recklessly slow to look at the entire file system for the classes like the Scala compiler does routinely today. And so they wanted to have like fast access, and that's why the name of the path has to match the name of the package exactly. And then jar files came along a little bit later, and of course now one has to look in 1,000 jar files, which is much slower than looking up something in a file system, and that's somehow okay, but that's how evolution works. Also notice there's no hierarchy, so if you have to say import java.util.star, that does not import another package, doesn't import java.util.concurrent. You can't say .star or anything. That's just how they work. So, and again, that's just for speedy lookup in 1995. Why are packages reverse domain names? Why is it com.horstmann? Well, I guess it could have been horstmann.com, but then it would have looked funny in the file system. But the reason for having these, the DNS names in the first place is to latch on an existing uniqueness mechanism. Only I was able to get horstmann.com. I've taken it, none of you can take it. And so it's the same thing with sun.com and oracle.com and so on. And so that way every company, every organization can guarantee uniqueness of their package names by simply buying a domain name and then using that and reversing it. Yeah. So yeah, let me not talk about modules in the interest of time. Another fun fact. Why are runtime exceptions called runtime exceptions? Doesn't every exception occur at runtime? So, think of Java has this complex system of exceptions for historical reasons. There is three kinds of, they're all throwables. They're errors that come from the VM itself. Then there are checked exceptions, such as IO exception, the one that we all love to hate, because we have to either catch or declare them. And then there are the unchecked exceptions that are subclasses of runtime exception. And hence my question, why the heck runtime exception? And so, this is all, really for reasons of history. So you all know you need to declare checked exceptions. And when you have an unchecked exception or a runtime exception, why didn't they call them unchecked exceptions? The runtime exceptions, then you don't declare them because you should make sure you don't generate them in the first place. Now, why are they called runtime exceptions? Because in ancient times, the null pointer exception, the array index out of bounds exception, and so on, were produced by a part of the Oak virtual machine called the runtime. That's a really dumb reason, I know, but that's why they're so called. So now you know. So they should have been called unchecked exceptions, and generations of people would have had an easier time learning it, but they were very busy in 1995, and they couldn't be bothered to change the name because there were already thousands of lines of Java code out there. All right, so I'm going to go through and see if there's anything that I particularly want to cover. Yes. So I'll cover a couple more things, and then I'll take time for questions. If you want to read the other things, you can later get the URL of the slides. So here's one of my most depressing slides. In Java 14, 15, 16, 17, they tinkered with the switch statement. And they did that to prepare us for something that's actually very nice, for something called pattern matching, where we want to be able to match not just on integers and characters and strings and stuff, but we want to be able to say, if something is, say, a point with 2 positive coordinates, then we want to do something. And if it's something else, we want to do something else. So they've been starting to tinkering with this switch. And in the process, we now actually have 4 kinds of switch. I don't know if you've ever seen them, but if not, here you see them for the first time. So in order to make it easier to teach, they decided to arrange them in these 2 axes. The interesting part of the new switch is it's an expression. So it's no longer, like in the old one, it's a statement where something happens in each of the branches. The new ones, each of the branches has a value. So if you look at this thing over here, you will see that if this string is one thing, then the value is one thing, and in the other branches, it's a different one. And that's what's called the expression switch. And you have the old statement form that you see down here, where there's no values being returned, and you have those breaks. You remember those breaks? Your teacher said, make sure you have a break at the end of each case. Then they said, well, those breaks, of course, are kind of icky, and so we could have another kind of switch statement where you don't have the breaks, where you just use the same arrows that they identified for the expression. And finally, they said, well, that's kind of, now you have 3, so we give you the 4th combination as well. So if you want to have an expression where you can use the values, then you put in breaks. They actually did that in Java 12, and it confused the heck out of everyone. And then they changed from break to yield. And so you have this form of switch expressions. So there's 4 kinds of switch expressions, and so they're arranged in these 2 axes in order to make them easier to teach. You have the fall-through versus the non-fall-through, and you have the expression versus the statement. And so whenever I show this to people who know Java, I'm in this Java champions group of people who know everything about Java, and I can stump them. So could you if you wanted to. And so it turns out that that design completely failed. They were not actually easier for teaching. And so the takeaway is that the new expression switch is great, use it, the one without fall-through. All the other ones, maybe the classic one you need because it was an old code, but stay away from the others. So sometimes these designs go horribly wrong. So it's interesting. I followed this, and it was like a train wreck happening, that people were talking themselves into this was a good idea, and nothing could deter them from it. Everyone who was teaching this says this is never going to work, and we know, no, it doesn't. That's sometimes how language evolution works. All right, so I'll give you one more example of something that's cooked up that's new, so that you learn some of the new features of Java. So strings, literal strings have been there for 20-some years, right? And so you could think, what else could one innovate? Well, you know that when you have a literal string, it's kind of a pain if you want to splice something in between, right? You have to close one string, you have to put a plus and a thing, and another plus, and then another string. Or if you have backslashes, like in a regex, then you have to put the double backslashes and escape them. So not as happy in stringland. In JavaScript, you'd use template strings to solve both of those problems. And so Java set out to do something about strings. And so since Java 14, there are these things called text blocks. And so it's the way it works is you have 3 quotes instead of 1 quote, followed by a new line, and then you can put arbitrary stuff in there. Your SQL expressions, your regular expressions, whatever, and then you put another 3 quotes. So that feature at one point was called raw strings, because anything that's in there, is completely taken the way it is, except it isn't. First of all, they said the embedded expressions we're not going to do. Maybe that'll come later. But then it occurred to them, there was a long discussion about this, that, and with various alternatives that were explored, so it didn't just occur to them. Everyone who did this discussion thought about this. What if you have 4 quotes in a row? Could happen, right? And at that point, then, of course, you have to somehow say, I don't want the string to end after the 3rd one, so you have to escape one of them. So now you do have to escape one with a backslash. And that means if there are backslashes in there, you have to escape them with a backslash, and they're no longer raw. So this is sad. There would have been better ways around this. So a really clever idea that they had at one point and then abandoned is, you always have this problem with a raw string, how do you know when to stop it? And so the earlier proposal, which I liked, is you can put any number of backticks. They use backticks instead of double quotes for whatever reason in that design. You can put like 15 backticks, and then the stuff inside can have up to 14. What if it had 15? Well, then you put one more at the boundaries, and that works. This design has actually now been taken up by C#. All right, so that gives you kind of a bit of an idea of some of the things that happen in a programming language as it grows. So every language, as it grows, gets complex. They started, hopefully simple, and they get, with every release, they get more complex. Java now has Java 18, so it's no wonder that you have this cruelty of complexity and backwards compatibility. You're not free to add in new features any way you want. You have to stay compatible. And that's just the way it is. It's not fatal, so you shouldn't say that Java is a bad language. Java is a great language, but it does have its share of imperfections. The designer of another programming language, C++, said that there's only two kinds of programming languages, the kind that no one uses and the ones that people complain about. So Java definitely is the one language that people complain about, but learn from its history, learn to appreciate its quirks, and it'll make you into a better programmer. So maybe I've answered some questions that you had about Java. That would be nice. If you have some more questions, we have, 10 minutes for them. And so I hope I made you think a little bit about language design. Thank you.
Thank you very much. Applause, thank you. And now we have a little bit of time for questions, so if any of you have questions regarding what was said, or just Java in general, or maybe programming languages, I'm sure you can get some insight. If you're shy to ask in English, then I can translate for you. So.
Yeah, or ask any question at all, and I'll answer the question that I wish you had asked. Anyone who asks a question, I understand, gets a t-shirt.
String interpolation. Why is it not in Java, given we now have multiple backticks? When is it coming?
Can you say that again? I did not hear.
Interpolating values in strings. When?
I'm sorry?
Interpolating values
when
in
interpolate strings are coming, not anytime soon. Right now it's off the radar.
Any other question?
How to prevent mistakes in designing a new language? Like if you want to design from scratch in like domain, how to prevent like unused?
Yeah. So the question is, how do you prevent these mistakes that apparently all these language designers make? Well, if I did it, of course, I would prevent all of them, or if you did them. No, I mean, every language designer, of course, starts with good intentions. So in Java, they did a pretty good job, if you think about it. I mean, they really did a fantastic job. It was a great improvement over what you had at the time. And so the kinds of things that I've been complaining about were kind of at the edges of the language, right? I mean, does it really bother you that there's labeled continue? As a purist, it defends us, but it's not really actively harmful. So there's two things that language designers do wrong, and they know that they do them wrong. The first one is that they want to be familiar with the past. So everyone picks up the parentheses and the braces because we're used to that from C++. C++ did that because we're used to that from C. C did that because we're used to that from Fortran. And Fortran was a horrible language. So that's really kind of unfortunate. Continue existed in Fortran. The other thing is that they earnestly designed something because they think it's going to be an improvement. That's where labeled break and continue come in for a more disciplined way of go-to, and then the complexity is just not worth the benefit. The same thing with the 4 forms of switch, 2 of which will hopefully never be used by anyone, and it was just an earnest desire to make something more logical that maybe if more people had looked at it. And that's often a problem. That the nice thing about these Java discussions is they all go on open mailing lists. So anyone can read them, anyone can put in comments. The sad thing, though, is that if people who are not on the design team put in a comment, it's not always taken seriously. But it does happen. And most languages, I think, are fairly well designed, except when they have a fatal flaw. If you look at JavaScript, JavaScript has one fatal flaw, and that is that it allows all these crazy conversions. If it wasn't for boolishness and the conversions from strings to numbers and numbers to strings, no one would complain about JavaScript the way that people do it now.
Thank you. Any other questions? Oh, I see. Why do they always have to be so far up?
Hi, thank you. So my question is, why not creating or writing or designing a whole new language that could be exactly like Java, but ruling out all these fatal flaws or all these errors in designing, basically?
Yeah. So that's a good question. And so people try, right? There's Kotlin, which went that approach. They said, we've learned from some of the goodness of Scala, and without using Scala's complexities, we'll put in some of the good parts. And so the first version of Kotlin was really nice. Now, of course, Kotlin struggles to stay compatible with its earlier versions and is going down the same road to ruin. So I think all you can do is give it the best shot. Why do I still stick with Java for everything? Because everyone knows Java. So yes, I know that I could save myself a few lines of code if I switch to Kotlin, but I would lose a certain part of collaborators. And if I don't specifically use it in a library that's optimized for Kotlin, I'm going to stick with Java and just deal with it. It's not that bad. So Java is pretty good, and by and large, it has gotten better over time, even though some gratuitous complexity. It would be wonderful if a brand new language came out. When Scala first came out, 10 years ago or so, I was really bullish on Scala. I thought everyone was going to gravitate to Scala, but Scala is pretty complex. And now there's a new version of Scala out there, Scala 3. I'm currently revising my Scala book to Scala 3. And I was very hopeful that this was going to be the salvation, all the complexity gone. But no, Scala 3 is complex in different ways. So it's really hard, and perfection eludes us.
Other questions? I think we have time for one, maybe more.
Thank you. Most of modern orient objective languages are using some kind of functional features like, I don't know, selecting something from list, and they used to do it like just getting collection and using these features on it. And Java is implementing all of this with this streams. Do you think it's a good idea? Because I think it complicates it mostly.
Okay, so there's different things to unpack there. So functional languages, right? Kotlin and Scala certainly have a more pleasant functional syntax than Java does, while still running on the JVM. So they're good languages to consider. Java is somewhat functional, except in this weird way that you don't actually have function types, but it's all done with these interfaces. You can live with it, but it's not perfect. It makes it hard sometimes to reason about what it does. Then there's the question of streams. I mean, streams are certainly an application of functional programming. You can do functional programming in in Java without ever using streams, or you can use streams. Streams have their benefits, and what you say correctly is when you use streams, it's a kind of a different way of describing your computational task. And I would say when that is appropriate, then it can be quite good. And it's just that now people have to know two ways of doing something, one without streams and one with streams. You can't really always use streams. And then people say streams are inefficient. That actually turns out not to be true. My friend Heinz Kabutz goes out and tells people, use streams. If you're worried that the loops are so much faster than streams, the data don't back you up. The only time that you should stay away from streams is with concurrent computations if you don't know what you're doing. So I think streams are fine, except it is another cognitive load that you have to learn them. And as for functional programming, yeah, Scala is definitely nicer and more functional.
Thank you. That was all the time we had for questions. So another round of applause. Thank you for coming. Thank you for the lecture. That was Professor Cay Horstmann.